Okay, good afternoon, everyone, and welcome to our NetC seminar. And today, from this seminar, we have our new friends coming from INSEE also joining us. Welcome. And today we have Daniele as our speaker. Daniele is a PhD student in physics and complex system at the University of Rome, Tor Vergata, and the Enrico Fermi Research Center, where she also served as a teaching assistant. He is currently a visiting researcher at the Network Science Institute in Northeastern University London. His research focuses on network science and statistical validation models. He also applies these tools to computational social science and LLMs to analyze social dynamics. And today he's gonna talk something about maximum entropy frameworks for online social networks. Welcome.
Introduction. Hello, everyone. Thanks for coming. So I'm going to talk about maximum entropy frameworks for bipartite complex network, and also we'll see a couple of applications in social science domain. So first of all, bipartite complex network are a powerful tool to structure a number of entities, for example, country products or plants, pollinator, mutualistic network like this. And the links are relation, and the weight is the intensity of this relation. So the main issues in this kind of networks are from big data. So there are a lot of noise and bias. So we can validate this kind of network with a null model. Today I'm going to talk about maximum entropy null model. So in a couple of words, we define a graph ensemble by fixing the expected constraints of a certain topological aspects of the network. And then we derive the null model probability distribution of the graph via entropy maximization under these constraints. So in the end, we estimate the model parameters that are Lagrange multiplier through the likelihood maximization under these kind of constraints. So in the end, we have a maximum entropy benchmark with fixed topological constraints. With this kind of model, we can, for example, validate directly the bipartite network. Also, we can study a direct relationship between the nodes of the same set, having a projection onto one of the two layers. So the state of the art about that is not considering at all the weighted version. So, for example, you can binarize this network with reveal competitive advantage, for example, and get into a binary network, and then project and, for example, study the concurrence on the same the relationship nodes of the same layer. But with this weighted advancement, we can study also the co-volume validation. So we don't neglect the weight and have a projection onto this layer, starting from the weighted version of the network. So we have, we're talking about this kind of null model. We have several. The bipartite configuration model is the oldest, the state of the art, considering the topology. Then we have the weighted version, considering the strength, the enhanced version, considering degree and strength sequence, and also a new null model, considering just the average connectivity, so just one Lagrange multiplier about topology, and then the weighted configuration model, so the strength sequence. So we focus on these four null model. So it seems the best is the bipartite enhanced configuration model. So we take into account degree and strength, but well, yes, but actually no, because it's very hard. So just for the bipartite configuration model, we have analytical solution. For the rest, we have numerical solution, but very hard, trust me. So me and my friend Lorenzo in CREF address exactly this point. So the computational aspect about the convergence, the parameters tuning for having a numerical solution with this kind of model. So you can expect the bipartite enhanced configuration model is the hardest to solve. And also the global connectivity approximation. So when you introduce the weight from in the bipartite network, and also, for example, you have a lot of degree variance or weight variance, the convergence is very tricky. And of course, the choice of the null model is crucial. For example, you can imagine extreme cases, the fully connected network on a sparse one. So, for example, for the fully connected is useless constrain the degree. And for the sparse networks, of course, the topology is important. So we have to see what's the easiest to converge and with the properly null model. So we did it. We passed the convergence issues, etc. So, for example, we test the behavior. For example, checking the reconstruction property, trivial property. For example, you can see in this plot the average degree reconstruction versus the empirical one. So for the bipartite enhanced configuration model in this case. So the advantages are a lot. So in this version, we did the convergence, and it works for several scales and also several domains. We test all networks we found, all bipartite network we found. For example, the mutualistic networks, economic, ecological network, textual networks, etc. So this is again the simplest check we can do it. So the average degree versus the empirical degree. We are focusing in bipartite enhanced version, the partial, so the average global collectivity, and also the enhanced. The enhanced one is the the diagonal. Of course, the weighted version not consider at all the degree, so the reconstruction is bad in this case. So the bipartite enhanced is the only model that link both degrees and connectivity and the weighted. So the enhanced version also is good with not trivial properties. For example, local reconstruction, ANN and SNN per network. So for example, the neighbors degree and the neighbors weights reconstruction. And also in global properties as clustering coefficients and nestedness of network. So we didn't expect that, but it's good. So high level of reconstruction sampling from the null model. And for what about model selection? Of course, the partial version is preferred a lot of times. Also, even the reconstruction, is better for the enhanced version because we calculated the Bayesian information criterion to a trade-off from between accuracy and density of the model. So the partial version has alpha of codegreens. So it is less complex than the enhanced version. So we tried also with the projection of covolume, as I told at the beginning. And also in this case, the partial version seems to be the optimal trade-off from the state-of-the-art configuration model and the enhanced version. Of course, instead of the reconstruction, we set the bipartite enhanced configuration model as our ground truth. So Also, you can see in the bottom the correlation between sorted p-values of the volume projection. And also, you can see high correlation calculated by Spearman coefficient, also between the state of the art and the approximation and enhanced version. So we had a good result about that. And in the end, we checked also the signal outcomes after the projection. So in this plot, you can see the Peixotto community action after validated the projection in the bipartite, the weighted version. And well, here we can see very different result, for example, for partial version. So we have to check and do your trade-off between the reconstruction and the complexity of the model, because in this case, we are seeing social networks in this case. And with, for example, with the partial version, we had completely different community structure. So meanwhile, the enhanced version is very similar, the state of the art. So you have to be careful which null model we can use. It depends from the networks and also from the level of reconstruction we have. So for now, we have just the binary version of the package. And also this package we did last year for the summer school we had in Rome. Is about economic complexity and also metrics, for example, fitness complexity. I don't know if you know, but and the validation metrics about the economics stuff. But as soon as possible, we developed a complete Python package with all these several null model, also weighted version. So please download. And now I want to pass to application in social science domain. So you all know social networks post negative aspects also in real world. We saw a lot of example social online issues move to a real world problem. For example, the Capitol Hill assault in 2021. We know we have issues in fact-checking on Meta, so researchers try to study and mitigate stuff like this. One of these phenomena are echo chamber, are well studied in social domain. Echo chamber, in a couple of words, are where people are exposed from the same information and where people talk with users that reinforce the pre-existing beliefs. So it seems that on Reddit, echo chambers are less clear. So we try to bridge this gap and try to understand if cross-group interaction, for example, limit polarization echo chamber, or the validation probably is the point. Briefly, we used a political data set on Reddit. His name is Politosphere. I don't know if you know. But we processed data set from 2013 to 2017. Consider also here beside is the 2016 where Trump won the presidential election. And we construct two kind of bipartite network. The first from users to subreddit. So a link is a comment by a user to one subreddit. And the second bipartite network is about the news sources. So we check if one domain is connected to a post on Reddit. So a link is a domain, for example, from Fox News, shared on that subreddit. So we then projected the bipartite network onto the subreddit layer. And through the community detection, we try to find the same communities between the interaction level and the news shared level. So basically, if we have a match between the two kind of communities, we have a place with people talk about the same stuff with the same people, and also based from the same sources of news. So basically, echo chamber. So thanks to statistical validation, we found community structure in interaction networks. And we found communities aligned with political topics or ideologies, stuff like that. And also we identified polarized communities, for example, Democrats, conservatives, that tend to separate, especially during the election, and also the banned communities. We label as ban those subreddits that will be banned in future. So, for example, the Donald that will be banned in 2019, or Le Pen subreddit or subreddit like this. And we have the polarization on these communities through the label propagation from the subreddit to user. So checking the composition of users in these kind of communities. So the polarization persists also during time, also during the election. And we saw also that general scores decline, particularly from Democrats, conservative, and banned ones, and in particular for the presidential candidate, especially the Donald and Hillary Clinton. So we did the same also for the domain level analysis. We identify very similar communities, so projected on the subreddit layer. And also here we can see that, for example, Democrats and conservative splits during the election persist the level of community all time. And so in the end, we did an echo chamber studying the overlap between these two kind of communities, and we validate again this time of matches, again with the null model. This time we weighted bipartite version, selecting just selecting the significant matches as a function of users that populate this kind of subreddit. So in the end, we found echo chambers on Reddit, and also that a significant number of users engage this kind of communities. And we just studied also the lexical pattern doing an embedding of the text of the post of this subreddit, finding also here a community structure as a function of this community tag. We also saw that during election, a lot of subreddit, so people sort with similar language, and that's a curious that in interaction network and his new networks, we have separate communities between Democrats and conservatives, but not from the language. We have more or less Donald Trump, Hillary, so liberal, work in very similar way from the election. So in a couple of words, what does degree validation imply? In this case, we use just degree validation from the bipartite network. So you can check the sorted adjacency matrix from the start, and then the validated one. So just a trivial check, remove the degree bias. Of course, for the co-occurrence, biggest subreddit have likely more concurrence, but with a validated version, no, we don't have anymore this kind of bias. And also, we see that uncover emergent community structure we didn't have without the validation. And so the point I want to stress is that a network can be dense or modular, okay, but we don't care. We are scientists, so we want stable outcomes. So as a function of, for example, arbitrary threshold, we can choose. And with this slide, I want to stress the point that without the validation, we can, for example, in literature, cut the network with the community distribution or with with arbitrary parameters. But if you have a probability for each link and shows, for example, a threshold, you have stable outcomes in terms of, for example, modularity and density, but also in the signal you analyze in the end after projection. So you can see the community detection as a function of significance threshold and also intensity threshold. So now we move to another project, small one, during the complexity 72 hour of last year. So we approached the language complexity online, testing if the beliefs about language complexity are true. For example, people say misinformation tends to lead to a simple language, or for example, far right wings. Other research say far right people talk more similar, simple way, but we checked completely another narrative. So this first slide, you just can see the vocabulary size as a function of number of trees, but of course, this measure is size dependent. So we move also to a independent measure about the size, and we computed the K complexity one. This is independent from the size of the vocabulary. We found that the more involved users, so for example, the users that have negative sentiment or political leaning well defined, are the one with more complex language. So you can try a very similar diagram for individual and organization, the Democrats, questionable and reliable content. So this is we didn't expect that, but was a good result. Again, very not aligned with the pre-existing literature. And in the end, thanks to validation, we could study also the influencer retweet network. Network between the influencer and the vocabulary. So we have a bipartite network between the influencer and the word they use. So showing that influencers sharing a similar vocabulary cluster, and also those clusters are aligned to political stance, and also with the questionable and reliable dimension. And this is a double check about the user involvement drive the more complex language. So in the end, just an off-topic project I start. I want to continue in next future to analyze and deep inside the validation of network, and also for characterizing the conversational pattern based from another physical tool, the Laplacian normalization group. And in this way, studying the Laplacian, and in particular the specific heat you can calculate from the network spectrum. In my opinion, you can check this and also study the characteristics of networks, and at the same time the characteristics of conversation. So in future we are going to study very different conversational tree from Reddit, also from Twitter, and compare, for example, alternative right subreddit conversation, or I don't know, geopolitical conversation, and seems the scale are changing, and it depends from the topic. Or for example, it seems that depending from the information and misinformation pattern inside the network. So to conclude, I'm going to fix my to-do list as soon as possible. So the package I told you at the start with several null model, And also I want to explore here and in future the hypergraph approach to capture social coordination and deep also with this dimension, try to characterize this conversation pattern, and also with the multi-scale approach I told you in the previous slide. Thank you.
Okay, thank you for the nice talk, for the detailed analysis of the social network. Any questions? I think Davide first.
When you were speaking about the validation, so the projection, a question about the p-values. I mean, okay, you know that
Here,
depending on the p-value that you decide, the level, significance, then the validated projection change, right?
Yeah.
So how do you approach this?
No, okay. Just for example, in the Reddit paper, we approach in the sense that we have stable outcomes. For example, from alpha equal to 0.01 to 10 to the minus 10. So it's not an issue, the validation threshold. If you use this kind of model, it seems that outcomes are really stable. So in particular, we use we compute p-values and then the FDR validation method, but
it's fine.
Stable as a function of.
Yeah, no.
Yeah, I wanted to ask you if you could explain again. So for the last project that you showed, the one from complexity, I missed what is the next slide. Next slide, sorry. The K complexity. What is it?
Is a measure. Okay, probably I missed the thing. Is a measure that anti-correlates with the complexity. So lower values of K complexity that measure the minimum description length of the your conversation. Your array is an embedded version of the sentence. So for lower values are the more complex. So that's the point. But we also tried a lot of measure. For example, the flash index. I don't know, but for example, the flash index consider the how much is complex the sentence, how much syllabs you have in the sentence, or also the gzip compression and other size independent measures, and we found a stable outcome about that.
Okay. So this is size independent, as I mentioned.
Size independent, yeah.
So it's capturing some other form of like complexity of the.
Yeah. Basically, it's normalized from the vocabulary size. Okay. Just the compression. You measure the potential compression of your text.
Okay. And sorry, that's another question. So you say more involved users. What does it mean exactly? Like, how do you?
Okay, we are dealing with the title of our publication, but good question. So, for example, okay, here I'm not showing you, but we have lower value for Democrats and Republicans, for example, against the not well-defined partisan. So involved in the sense that if a person comments a lot, also have a negative sentiment or have a well-defined parties, for example, is Democrats or is Republican, or for example, is also a simple questionable. It means for the COVID-19 dataset is, for example, is Novax. So person really involved in conversation that come as a clear parties in discussion. The dataset, for example, are very specific about this. One is about COVID. one is about climate change conference, COP26, and the other is about the Ukraine war. So people tend to decide one stance or remain in gray zone. So that's the meaning of involvement. The meaning of involvement. I don't know if I explained well.
Okay, thanks.
Okay, any other questions? Okay, I have a question. In the last slide, you mentioned about the hypergraph and the high order interactions in the network. But from my perspective, your original network, the bipartite network, it is actually a higher order network. And so if you want to do some more analysis about the higher order interactions, are you going to focus on the original bipartite network, or are you going to also transfer it to the other forms and analyze it?
Okay. First of all, specifically, I don't want to construct hypergraph of that data set. So I mean, capture social ordination, also trying to analyze different patterns. So for example, coordination patterns, completely different hypergraphs. So for example, more like this, more than, for example, conversation trees. You can decide the order of your link, basically as a function of time. People put text under the post of Reddit, so it come down. So you can build a graph in this sense. I was thinking about conversation trees, but probably I agree with you that you can consider two bipartite networks as a hypergraph, but okay. So it's another way to see this stuff. Actually, an hypergraph that is a.
And I also think the original network, it also contains a lot of noise. So that's why I have that question. So, okay, thank you.
Thank you for the talk. And so I wanted to understand, maybe I got like a bit, like I lost important details from the beginning. But so the maximum entropy like methods that you like describe at the beginning, so these ones, so these ones are the ones that can help you to identify the communities in the other like part of the work. Is that correct or not?
Yeah.
Also.
Yeah. With this kind of model, you can filter significative links.
Okay.
And then, also uncover emergent structure. Probably you cannot have without this kind of validation. So we have million of links. When you do basically every community detection tool, you can see anything. But it's not, as I told in the end, it's not a question of communities, but a question of stability of the signal. And then also is correlated that you can find communities in this way.
So then the maximum entropy is kind of like you're just like making a previous filter.
Yeah.
Just to like take the like more essential like I don't know structure in the network.
You have a maximally random benchmark with certain topological fixed constraints. So you assume the minimum number of constraints, and then maximizing the entropy, you find the probability distribution of the graph. In the end, you have basically a probability for each link in your bipartite network. So from that, you can calculate a p-value of each connection.
Okay.
You can have also in the projection, just with numerical solution. I mean, but for the weighted version, but you have.
Okay. And so in the thresholds that you mentioned at the end with this, for example, the stability, are related to how you are doing this kind of filtering. So how do you are discarding, I don't know, like like taking the essential links or not the essential links. Is that the case or not?
Probably I can understand. I don't get the point.
So sorry. So at the end, so you mentioned it's not about the convenience, but it's about the stability of the signal. And then when you change the thresholds, these thresholds, what are these thresholds? Is threshold related to what? To the
related to the significance threshold in your null model. So basically, you have a probability distribution, right? And then you can sample. You can sampling from these, and so extracting sample, you can calculate your p-value about your link. So yeah, the stability I told you was about this significant threshold.
Okay.
You have to put in advance right after you build your normal distribution.
Okay.
Oh, I don't know if I explained well, but
Don't think so.
ask if you want.
Thank you. Thank you.
Any other questions?
I have a quick question about the trees that you're working with, or you're planning to work with. What are you going to do with it? Because I'm working with Reddit as well. So I want to know what you're going to work exactly on the trees.
You mean in the future, the next step?
Yeah.
Okay. With the hypergraph, I want to so as I wrote, capture social coordination in the sense that I want to study conversational tree on Reddit or Twitter, for example, and try to see if more than two can show us, for example, a sort of transition phase in network abstraction in conversation. So, for example, I don't know if you know the words about GameStop squeeze, for example, of my collaborator, Antonio Desiderio, Giulio Gemini, etc. So, for example, starting from this point, you can explore the conversation tree and try to see if with the hypergraph approach in these trees, you can, for example, see the squeeze or see the signal, a sort of transition phase before data told you. So a kind of prediction about what will happen in data. So this was the idea. Now we are thinking about that. The data try to explore the dimension. And with the Laplacian normalization group, so basically the multi-scale approach, I want to check mainly the information level, information and disinformation level. So also from your conversation tree, I hope I will see if a kind of you can connect a kind of structure with, for example, a disinformation phenomena or not. So these are ideas for now. Was at the very beginning. Okay.
Yeah, I'm curious to know how you're going to group the second or whatever order groups that you're going to create, because I had this idea a year ago, but I couldn't do it because I just don't know how, because it's difficult to group these things into like a high order groups, because there are many ways to do it.
Yeah. Many ways. You can consider time, the time of replies under your tree, for example. Also the topic. For example, you are talking about I don't know Trump's, so or Hillary. You can choose the order as a function of the topic you're talking about. So topic, time, also where in your framework. So, for example, under which trees you are relying, or under on which subreddit, for example. So I agree. You can construct it several ways, but I think time is the key. I'm starting with the time. For example, this example, I did networks as a fashion of snapshot hour. So we saw that trees are changing with the time. So we reach a sort of stability, which of a certain time, for example, we can call characteristic time, for example. And then, yeah, this is one way, but there are several.
So one quick question about the interpretation maybe of the so you mentioned that at the end, so at the beginning, the idea was that in Reddit there are no echo chambers. That was like the idea before, and so you're kind of like saying no, you're challenging maybe this, saying that there exists polarization. So why was the case that like before they didn't identify this? Like why they believed that there was no echo chambers, or like what was missing that, for example, now with this you managed to see?
What I think is probably is a problem about data, the choice of data, and also threshold, and the fact that they use properly validation tool. Because I chose this paper, but is a little bit famous in this field, but there are several. But basically, what they did is, okay, I choose a couple of subreddit, and then I choose arbitrary. I don't want to seem rude, but more or less this is the situation. So people try to cut the network at a certain point. Obviously, if you consider the 2016 case where Republicans and Democrats trying to replies again and again day after day, you see a lot of noise. So you cannot see polarization or echo chamber at all, because what you're seeing is a random network, probably. And a lot of paper, according to me, probably use also a kind of null model. But the point is also that people selecting network or part of network in arbitrary way sometimes. And for example, an advantage of our approach is the fact that we consider all political subreddit, more or less, and so huge network from what Democrats and conservative signals emerge by itself. I didn't do anything about that. Pick up the bipartite networks and validating, and we'll see. So probably if you consider just one subreddit, a couple of subreddit, try to build by your own the networks, it's very difficult to uncover structure or phenomena like this. My opinion also. It can publish on Nature.
Thank you.
More questions? Nope. Okay, so thank you all for attending the seminar, and thank you people online, and thanks Daniele for giving us the
again.
talk.